Most of the world didn't have it until colonization started in the 15th century. It didn't exist in Southern Africa, it didn't exist in Asia. It was only in Europe.
Type O blood has always been quietly extraordinary, a universal donor, a medical lifesaver. But in 2025, scientists uncovered something much deeper. This wasn't just a neutral blood type, it was a genetic time capsule, one that tells the story of extinction, survival, and a hidden catastrophe that reshaped the bloodlines of entire continents. As researchers followed the clues across ancient bones, remote islands, and forgotten immune codes, a chilling truth emerged, and what they just revealed about Type O blood has left scientists speechless. The blood that wouldn't go away. In the sprawling annals of medical science, blood types were once relegated to a practical role, the simple life-saving system that allowed doctors to match donors and recipients during transfusions. Among the ABO groups, Type O held a special place, the universal donor, prized for its lack of surface antigens, making it a biological wildcard that could flow safely into almost any vein. For years, Type O blood was seen as little more than a clinical convenience, a footnote in textbooks. But this seemingly mundane detail began to reveal a profound mystery as scientists turned their attention to the indigenous peoples scattered across the Americas. From the steely reaches of Alaska's tundra to the dense, whispering jungles of the Amazon, a striking pattern emerged. In these communities, Type O blood wasn't just prevalent, it was overwhelmingly dominant, almost to the point of exclusivity. Among certain Amazonian tribes, for instance, nearly every individual carried Type O. The same pattern repeated in isolated Andean villages and remote Arctic hamlets. Samples collected over decades told a uniform story: the near-total absence of A and B blood groups, replaced almost entirely by the silent, blank Type O. At first, the scientific community treated these findings as mere consequences of isolation. Genetic drift, founder effects, population bottlenecks, these were convenient explanations for what seemed like a simple quirk of evolution. But the more data poured in, the less satisfactory those answers became. The purity and consistency of Type O in these populations didn't look like randomness or accident. It appeared purposeful, like a silent code etched into the very bloodlines of these peoples, passed down through thousands of years without deviation. The puzzle in plain sight. To the casual observer, the ABO blood system might seem straightforward. The presence or absence of certain antigens on the surface of red blood cells defines our blood type. Type A blood carries the A antigen, Type B the B antigen, Type AB carries both, and Type O carries none. This absence is what allows Type O blood to be a universal donor. It doesn't trigger the immune system's defensive alarm bells, making it compatible across other types. But this simplicity masks a deeper biological story. In nature, the absence of something can often signify the oldest, most primordial origins. Type O blood, blank as a clean slate, may actually represent the ancient core from which other blood types evolved. It's not merely a passive absence, but a resilient, enduring foundation of human blood history. Unlike other blood groups that shift and mutate over time, Type O displays an unusual stability, a genetic conservatism that resists change even as populations spread, mixed, and evolved in diverse environments. Geneticists, armed with ever more sophisticated models and statistical tools, mapped the global distribution of ABO blood types with unprecedented precision. What stood out, glaringly, was the sharp contrast in the Americas. While populations across Europe, Asia, and Africa exhibited a rich mosaic of blood types, indigenous populations in the New World seemed to cling almost exclusively to Type O. This was not a mere quirk of geographic isolation or migration patterns. The real puzzle was the absence itself. Why had other blood types faded away, or been removed entirely from these gene pools? The pattern was too clean, too absolute, to be random. Something, or someone, had acted upon this genetic landscape. Natural selection alone did not offer an adequate explanation. The missing diversity was a puzzle in plain sight, waiting for a theory that could explain why Type A and B had all but vanished, leaving an ancient bloodline untouched and unchallenged. The answers, if they existed, were hidden in the shadows of history, genetics, and perhaps even human migration itself. To unravel this mystery, scientists would have to challenge assumptions, confront silences, and follow the trail of the blood that wouldn't go away. The ice bridge theory starts to crack. For generations, the prevailing story of humanity's arrival in the Americas rested on a singular, compelling image. Small bands of ancient people, braving an icy wasteland, crossing a vast land bridge known as Beringia, which once connected Siberia and Alaska during the last ice age. This land bridge, exposed when sea levels fell dramatically, was thought to be the sole gateway for human migration into the New World, roughly 15,000 to 20,000 years ago. The migrants were believed to be a tiny population, maybe a few hundred individuals at most, carrying with them only a fraction of the genetic diversity present in their Siberian homeland. It was a bottleneck, a narrow genetic funnel through which all subsequent indigenous peoples descended. According to this traditional anthropology, this bottleneck explained the overwhelming prevalence of type O blood among indigenous populations in the Americas. If the founding migrants carried predominantly O alleles and little to no A or B variants, then isolation over thousands of years would naturally preserve and even amplify this dominance. It was a neat and tidy explanation, fitting the puzzle pieces together with reassuring simplicity. However, as genetic science grew more sophisticated, the neatness began to unravel. Ancient DNA extracted from Siberian remains near Lake Baikal, dated to the same epoch, revealed a different story. Far from being a homogeneous pool dominated by a single blood type, these ancient Siberians displayed a rich mosaic of blood groups, A, B, AB, and O, all coexisting. The same genetic diversity was evident in early East Asian populations as well, indicating that the ancestral gene pool was far more complex than once thought. This complexity posed a glaring question. If the ancestral populations had such a variety of blood types, why did this diversity not survive the crossing into the Americas? Why, upon arrival, do indigenous populations overwhelmingly show only type O blood, with near total absence of A or B? There was no gradual blending or dilution of blood types that might be expected from isolated evolution. Instead, there was an abrupt collapse, an almost complete disappearance of blood diversity, a genetic void where A and B should have been. Such a stark shift defied simple explanation. Either the early migrants to the Americas were exclusively type O carriers, a scenario at odds with what Siberian genetics revealed, or a catastrophic event had eliminated all other blood types after the crossing. The implications were profound. Was the land bridge theory incomplete, or was there a hidden factor, something lethal, that reshaped the genetic landscape of the Americas in its wake? The vanishing bloodlines. By 2025, this mystery entered a new phase of scrutiny when a coalition of immunogeneticists from Canada, Brazil, and South Korea unveiled a groundbreaking study that sent ripples through academic and scientific communities worldwide. Their ambitious project had focused on sequencing ancient DNA from skeletal remains scattered across North America, Siberia, and early Polynesian sites, aiming to track the movement and evolution of blood type alleles through time and geography. The results shattered many long-held assumptions. Indigenous remains from various sites, all dating to after the hypothesized Beringia crossing, showed a near-complete absence of A and B alleles. This was not merely a quirk of small sample sizes or incomplete data. Patterns repeated across continents and cultures, pointing to a sweeping and profound genetic shift. Yet, the data revealed something even more unsettling. Early skeletal remains in Alaska, closer in time and space to the original migration event, still carried faint traces of type A blood. This suggested that A alleles had indeed crossed the land bridge with the early peoples. But somewhere between Alaska and the central plains of North America, these alleles disappeared completely. They were wiped clean from the genetic record. This vanishing act could not be explained by simple isolation or random genetic drift. Instead, it suggested a powerful and selective force actively removing non-O blood types. But what could be so selective and so deadly? Speculation ranged from devastating epidemics sweeping through vulnerable populations to intense genetic bottlenecks triggered by environmental cataclysms. Some proposed a previously unknown pathogen or immunological crisis that targeted non-O blood types specifically, creating a brutal and unprecedented natural selection event. The researchers themselves refrained from definitive conclusions, leaving their interpretations open. But their paper's abstract contained a sentence that slipped past many readers, a quiet but chilling hint. The data imply a directional selection event, potentially immunological in origin, favoring O alleles over all others. Put plainly, the evidence pointed to a hostile event that hunted down and decimated carriers of A and B alleles, allowing only type O bloodlines to survive and multiply. The silent genetic scars of this catastrophe were embedded in the DNA of millions, a biological fingerprint of survival and loss. And yet, despite the gravity of this discovery, the academic world had only begun to scratch the surface. Behind the closed doors of conferences and buried within the stacks of restricted papers, whispers persisted that the full truth had been obscured. For decades, for reasons still unclear, they hid this. The story of a bloodline purge so profound, it reshaped the very fabric of human ancestry in the Americas. The immunity rift. As scientists peeled back the layers of human genetics and immunology, the extraordinary resilience of type O blood carriers became impossible to ignore. Unlike other blood types, type O seemed to hold within it a quiet strength, an immunological edge forged through millennia of relentless survival battles against some of the deadliest pathogens known to humanity. This wasn't mere speculation. Researchers observed that people with type O blood exhibited distinctive immune response patterns. Their bodies responded to infections such as cholera, malaria, severe dengue fever, and even newly emerging respiratory viruses with a remarkable clarity. The immune system's attack was efficient yet measured, avoiding the disastrous overreactions that could prove fatal. Their clotting mechanisms, a crucial factor during infections, were notably less prone to causing harmful clots, and their inflammatory responses were better balanced, preventing excessive tissue damage. This delicate harmony didn't grant them immunity in the absolute sense. They still fell ill and sometimes succumbed. But it did tilt the survival scales in their favor, granting a subtle but consistent advantage over centuries of epidemics and environmental hardship. Nowhere was this advantage more vividly apparent than high in the South American Andes. Indigenous communities, isolated and cut off from modern medical advances, thrived in these unforgiving highlands. Here the air was thin, the sun merciless, and infectious diseases a constant threat. Yet these populations endured, their health surprisingly robust. Genetic analyses revealed a significant prevalence of type O blood, paired with a remarkable immune-modulating gene variant, known scientifically as IL-17 variant 52C. This gene variant seemed to act like a biological thermostat, calming the dangerous cytokine storms that often accompany severe infections, where the immune system spirals out of control and causes devastating damage. The presence of interleukin-17-52C suggested an evolutionary refinement, a way the immune system had adapted not just to survive infections, but to survive them without self-destruction. What was chilling, however, was the implication behind these discoveries. This wasn't a random chance. It was the unmistakable fingerprint of survival through some massive, silent, and likely catastrophic biological conflict. Something had repeatedly threatened the very existence of these populations, applying pressure so severe that only the genetically best prepared endured. Yet these groundbreaking findings remained locked away in obscure scientific journals, never making headlines or stirring public debate. Why was this buried knowledge? The answer was as unsettling as the discovery itself. If type O blood and associated immune traits were the result of natural selection during a near-extinction event, it forced humanity to confront a haunting question. What colossal threat did our ancestors survive? A threat so profound, so catastrophic, that it left no direct memory but forever shaped our biology. The Lake Baikal marker. Thousands of miles away from the Andean peaks, in the frigid reaches near Lake Baikal, archaeologists unearthed a relic that would deepen the mystery even further. Encased in permafrost, preserved through millennia, lay a human skull dated to over 12,000 years ago. DNA analysis of this ancient bone promised to rewrite parts of history, connecting the deep past with present-day lives. Within the genome, scientists found something extraordinary: a rare haplogroup, an inherited genetic signature, shared only with certain indigenous peoples of North America, notably the Blackfeet Nation in Montana. This genetic bridge across time and space whispered of ancient migrations, frozen footprints on the landscape of human evolution. But even more astonishing was a peculiar mutation embedded in the ABO blood group gene cluster, a deletion mutation they dubbed the O-delta variant 1. Unlike the more common substitutions or single-letter changes in DNA, this was a deletion, a more dramatic genetic event that signified a strong adaptive response to an extreme environmental or pathogenic pressure. What made this mutation all the more fascinating was its exclusivity. It did not appear in European, African, or even East Asian populations. It was a genetic hallmark found only among select indigenous lineages who had not just migrated from Siberia across Beringia, but had endured the brutal ice age, survived massive climate shifts, and rebuilt their communities in relative isolation from the rest of the world. This discovery was not merely a scientific curiosity. It was a profound testament to survival, etched into the very fabric of blood. The blood itself seemed to carry the memory of ancient threats, biological battles fought and won long before recorded history. Faced with this evidence, the scientific community confronted a new question, one that unsettled the boundaries of anthropology, genetics, and human history alike. What was this blood defending itself from? What invisible enemy forced such radical genetic adaptations in the deepest shadows of prehistory? The answer remained elusive, but the questions opened a door to a forgotten chapter of human endurance, a chapter written not in words, but in DNA. The Crawford Revelation. In the early months of 2025, an event unfolded that allegedly sent ripples through the intertwined worlds of genetics and anthropology, an unexpected discovery sparked by a man few would have predicted: Thomas Crawford, a Native American living on the Blackfeet Reservation in Montana. What began as a routine DNA submission for a large-scale ancestral bloodline mapping project quickly evolved into what some are calling one of the most profound and mysterious scientific revelations of the decade. Crawford's genetic profile was anticipated to align with known ancestral lineages, confirming familiar historical threads. Instead, it allegedly uncovered something far more complex and unsettling, something that no one, not even the experts, had truly anticipated. The blood sample revealed the presence of the well-documented O-delta variant 1, a genetic signature previously traced to ancient populations near Lake Baikal in Siberia. Yet, alongside this marker was an entirely unprecedented genetic fragment, a regulatory sequence located on chromosome 6, nestled near the human leukocyte antigen HLA region, the critical control center of the immune response system. What made this sequence especially intriguing, if not downright baffling, was its synthetic-like structure, displaying patterns that allegedly defied the expectations of natural evolutionary processes. For decades, this stretch of nucleotides had been dismissed as so-called junk DNA, presumed to be functionless. However, cutting-edge immune modeling simulations now suggested this region was anything but inert. Remarkably, this enigmatic fragment seemed to activate only under extreme biological duress, specifically during multi-organ infection combined with acute oxygen deprivation, a state biologists often term a death spiral. Under these dire conditions, rather than shutting down as most genes would, this sequence allegedly sprang to life with an almost defiant resilience. In Crawford's blood, it was as if a hidden genetic code was fighting back, a secret layer of defense possibly engineered or evolved to survive the unthinkable. The implications sparked urgent and unsettling questions. How had this mysterious sequence become embedded in the human genome, and why was it seemingly preserved only among type O blood carriers? Equally puzzling was the conspicuous absence of any reference to it in Western medical literature or global genetic databases. The silence surrounding this discovery was deafening. The breakthrough came from an unlikely source, a whistleblower within the shadowed corridors of the Human Genome Archive. a vast repository of genetic data managed by powerful international scientific institutions. This insider reportedly revealed, almost in a whisper, that this peculiar genetic pattern was first identified back in 1998, but had been systematically buried and suppressed from public view. They found this pattern in 1998. It got buried, the source confided. Those words lingered ominously in the air. Allegedly, they hid this, the Polynesian Passage. As geneticists broadened their scope beyond the North American and Siberian nexus, the story of type O blood allegedly stretched far across the Pacific Ocean, into the vast and enigmatic expanse where even more astonishing findings awaited. On Rapa Nui, better known as Easter Island, archaeologists uncovered skeletal remains dating back roughly 900 years. These ancient bones were not just relics, but genetic time capsules, potentially holding secrets of transoceanic migrations and intercultural contacts that defy conventional historical narratives. DNA extracted from the Rapa Nui remains revealed a notable prevalence of type O blood. Yet the most provocative finding was the presence of the IL-1752C immune variant, the same genetic signature associated with enhanced immune modulation in South American highland populations. This suggests direct gene flow between Polynesian voyagers and South American coastal peoples centuries before European colonization, a theory that challenges long-standing assumptions about the Pacific as an insurmountable barrier prior to the age of exploration. Instead, this paints a picture of deliberate ancient voyages, crossing vast oceans not only of geography, but also of genetic legacy, where people shared more than just culture and artifacts. They shared survival itself. Further analysis of ancient Andean teeth uncovered microbial traces and immune response markers previously unknown to modern microbiology. The antibodies detected were tuned to pathogens that are now believed to be extinct, ghostly echoes of diseases that shaped human evolution. Strikingly, these immune signatures were overwhelmingly concentrated in individuals with type O blood. Other blood types, it appears, did not survive the waves of disease and environmental catastrophe that swept through ancient populations. It was not simply that type O endured, it was allegedly the only blood type to do so. These revelations raise haunting questions. What cataclysmic events sculpted human survival so dramatically that only one blood type and its unique genetic arsenal emerged intact? What horrors did our ancestors endure, and how has their legacy been meticulously encoded in millions of people today? While the answers remain tantalizingly out of reach, they beckon humanity to peel back layers of forgotten history. The hidden history of human collapse. With the passage of time and advances in genetic technology, the emerging data became impossible to ignore. Researchers began piecing together an ancient narrative, suggesting a brutal population bottleneck in the early Americas, an event so catastrophic it allegedly rewrote overlooked, or quietly forgotten because it threatened the comforting narratives of human history. But the blood remembers. If your blood held a secret from the ancient past, what would you want to do with that knowledge?
Yep.